Today in this video, we are going to discuss about alcohols, phenols, and ethers. So first of all, what are alcohols? So when one hydrogen of aliphatic hydrocarbon, I hope all of you know what are hydrocarbons. These are the compounds made up of carbon and hydrogen. Now aliphatic hydrocarbon which are having open chain structure, these are called aliphatic hydrocarbon. So when one hydrogen of aliphatic hydrocarbon is replaced by OH group, then we'll get alcohol. We can understand it with simple example of methane. So when one hydrogen of methane is replaced with OH, then we'll get methyl alcohol or methanol. Similarly, if we replace one hydrogen of C2H6 with OH, we'll get C2H5OH, that is ethyl alcohol or ethanol. So all these are alcohols. Okay. Now next we'll talk about phenols. Now how we get phenols? When one hydrogen of aromatic hydrocarbon. Now what do you mean by aromatic hydrocarbon? Aromatic hydrocarbon which contains benzene ring. Now formula of benzene is C6H6 and this is the structure of benzene ring. I hope all of you know about it. Now, if one hydrogen of benzene ring is replaced with OH, we'll get aromatic hydrocarbon. We'll get phenol. There are various types of phenol. Now, these alcohols and phenols, these are very important compounds because many daily life items which we use, like spirit, then sugar, cotton, all these contain the compounds which are having OH groups. So these are very important. Now, what are ethers? When we talk about ethers, if the hydrogen of alcohol is replaced with any alkyl or aryl group, suppose this hydrogen is replaced with methyl, then we are going to get CH3O CH3, which is one of the example of ether, and this is dimethyl ether. Okay, now we'll discuss the classification of alcohol, phenol and ethers. So first of all, we'll discuss about alcohols. Now alcohols can be classified as mono, di and tri or polyhydric. Okay, polyhydric alcohols. Now, what do you mean by monohydric alcohol? So when we talk about monohydric alcohol, so if hydrocarbon is having only one hydroxyl group, like this C2H5OH, this is monohydric. Similarly, this is the benzene ring. If in this benzene ring, only one hydroxyl group, one OH group is attached, this is also monohydric. Now dihydric. Now dihydric means if aliphatic chain is having, aliphatic hydrocarbon is having two OH group, this is dihydric. Similarly, in the case of aromatic or benzene, if there are two OH group attached to this ring, it is known as dihydric. Okay, now trihydric alcohol, trihydric alcohol, if this aliphatic hydrocarbon or open chain structure is having three OH group, this is called as trihydric. Similarly, in the benzene ring, if three OH groups are attached, okay, so it is known as trihydric. Okay, so and polyhydric means if more than three OH groups are attached to any open chain structure or benzene ring, then it will be polyhydric. Okay, now monohydric can be classified on the basis of hybridization of the carbon atom to which OH group is attached. Okay, so in this category, the first category is in which OH group is attached to the carbon which is having sp3 hybridization. I hope all of you know about the hybridization. So first of all, discuss about this category of alcohols. Now this category of alcohol in which OH is directly attached to the carbon which is having sp3 hybridization. It can be categorized as primary, secondary, and tertiary. Okay. So first of all, primary alcohol. Now what is primary alcohol? Now here you can see that this OH group is attached to the carbon and this carbon is having sp3 hybridization. So it will be called as primary because this carbon is attached to one more carbon atom here. Now secondary. Now when we talk about secondary alcohol, so here the carbon is having sp3 hybridization and this is attached to two more carbons. So that's why it is called as secondary. Okay. So it can be represented like this also, 1 degree, 2 degree. Now tertiary. So in tertiary alcohol, this carbon is having sp3 hybridization and this OH group is attached to this carbon and it is attached with three more carbons. So it is called as tertiary, okay, alcohol. Okay. Now next category is allylic alcohols. Now what are allylic alcohols? Now when we talk about allylic alcohols, in these compounds, the OH group is attached to a sp3 hybridized carbon, but this carbon is attached to a carbon which is the carbon-carbon double bond. Okay, let me explain you with one example. And here also we are having three categories: primary, secondary, and tertiary. Like this example, this is example of allylic alcohol. Here this carbon is having sp3 hybridization and it is attached to the carbon which is attached with the double bond. So this is primary allylic alcohol. Now when we talk about secondary allylic alcohol, okay, so here this is the example of secondary allylic alcohol because this carbon is having sp3 hybridization and it is attached with one carbon here with single bond, and here also this carbon it attached with this carbon which is having double bond here. So this is secondary allylic. Now tertiary. Now when we talk about tertiary allylic alcohol, so here you can see that this carbon to which the hydroxyl group is attached. Okay, it is attached with three carbons and next to this carbon there is a double bond. So basically what are allylic alcohols? Allylic alcohols are the alcohols in which OH group is attached to a sp3 hybridized carbon next to carbon-carbon double bond. Now next, benzylic alcohols. Now what are benzylic alcohols? So when we talk about benzylic alcohols, it is related to benzene. Okay. Now here the OH group, this OH group is attached to the carbon which is having sp3 hybridization, but this carbon is attached to the benzene ring or aromatic ring. Okay, so this is the example of benzylic alcohol and it is primary benzylic alcohol. Now when we talk about secondary benzylic alcohol, what we have to do, there will be a benzene ring and this carbon is attached to this benzene ring and this carbon is attached to one more carbon also. So this carbon is having sp3 hybridization and it is attached with this carbon also and benzene ring also. So that is, it is secondary benzylic alcohol. Now, when we talk about tertiary benzylic alcohol, for tertiary benzylic alcohol, again, we need to draw the benzene ring. Here, this carbon is attached, which is attached with two more carbons. Okay, means total, this carbon is attached with three carbon atoms, one here and two here, and then this hydroxyl group. So this is tertiary benzylic alcohol. Okay, it is tertiary benzylic alcohol. Now, next category of alcohols in which OH group is attached to a carbon which is sp2 hybridized. Okay, not sp3. So here we'll discuss about, firstly we'll discuss about vinylic alcohol. So when we talk about vinylic alcohol, here I'm writing this example. Okay, now this carbon is having double bond, so it means it is sp2 hybridized, and OH group is attached to this, so it is vinylic alcohol. Okay, now next is next example we can take the of benzene ring. Now in this benzene ring, if the OH group is directly attached to this carbon. Now all of you know that this carbon is having sp2 hybridization. Okay, so this is also vinylic alcohol and it is a phenol. Okay, next example, one more example of this. I'm drawing it here. So this is also example of vinylic alcohol, because here the OH group is attached to the carbon which is having sp2 hybridization. Now we'll discuss about ethers. Okay, now when we talk about ethers, I've discussed with you earlier that when one hydrogen is replaced by alkylic or arylic group, we are going to get ethers. Now ethers can be simple, okay, symmetrical, simple or symmetrical, or unsymmetrical. Okay, two type of ethers are there, symmetrical and unsymmetrical. Now in which case the ether will be symmetrical if both the groups attached to oxygen are same. Like here you can see, so this type of ether is symmetrical. Okay, here you can see two methyl groups are attached and it is dimethyl ether. Similarly, we can take one more example. Again, it is a symmetrical ether, both diethyl ether. So these are symmetrical because both the groups which are attached to the oxygen are same. Now, what are unsymmetrical ether? If I write example CH3O C2H5. Now here it is CH3 group and here it is C2H5 group. So it is unsymmetrical. Okay. Or you can take one more example like C2H5O C6H5. It's an aryl group and it is alkyl group. So these are unsymmetrical ethers. Okay. So this is the introduction part. Now next video we'll discuss about the nomenclature of alcohols and ethers.